Okay. So the first thing that we actually need to do is finish up our discussion of bottom heavy and top heavy. We talked about when the top and the bottom have equal degree. What is our end behavior asymptote if we have equal degree? This is where we ended yesterday. What'd you say? They're both going to be going the same way, but specifically, how do I find that end behavior asymptote? Is it oblique? Is it slant? Is it horizontal? It's horizontal if they are equal degree. And then how do I find it? Y equals not 0 for equal degree. It's going to be the ratio of my leading coefficients. For the bottom heavy, this is where I'm looking at Y equals 0 when it is bottom heavy. Y equals 0. And again, when we're talking about top heavy and bottom heavy and all of that, that is when it is in quotient form. Oh, thank you. Let me fix that. Thank you. When I'm in quotient form, so f of x equals p of x over q of x. This whole thing just froze on me. Come on. Sorry, I'm not trying to put those on there, but this just decided to get weird. So strange. All right, hold up. I'll get this up in just a second. Why did it do this? Oh my goodness. I love new technology. It's fantastic. Mm-hmm. Brand new tech. Okay, there we go. Now I can get some of this weird stuff off of here. I don't know what just happened, but I think I fixed it. F of x equals p of x over q of x. All right. Oh, and it did it again. Good grief. Okay. Thank you guys for your patience with me. There's so many new buttons to push that I didn't even know existed until yesterday. Are both of these bottom heavy? No. Which one is? First one on the left over here. This guy is bottom heavy. He's degree 2. Up on the top, I have a degree 1. So for this one, I have a horizontal asymptote at y equals 0. All right. Technically, this is following from how I do equal degree. The top is only a degree 1 polynomial, so how many x squareds do I actually have up in my numerator? 0x squared. So this is 0x squared plus x plus 3. So when I look at those leading coefficients there, I have 0 over 1, which is why my asymptote is at 0. So it's following the exact same process as when I have an equal degree. You guys told me that this one was not bottom heavy, which I agree with you on. What form is it in? This is in transformation form. When I'm in transformation form, f of x equals a over x minus h plus k, where x equals h is my vertical asymptote. and y equals k is my horizontal asymptote. What is my horizontal asymptote here? Y equals -4, yes. We could find a common denominator, x plus 2, multiply that -4 by x plus 2 over x plus 2, combine them together, and then we would see that we have equal degree top and bottom. It would no longer appear to be bottom heavy. When we talk about equal degree, bottom heavy, top heavy, it has to be in P over Q form. All right. One more thing, and then I want to get to an actual graph, and we'll do more graphing on Monday. But when I'm looking at bottom heavy, or sorry, top heavy, my apologies. We just looked at bottom heavy. When I'm looking at top heavy, this is the only place where I'm going to have a slant or an oblique asymptote. We're going to have to use longer synthetic division to find that. So how would I set up this synthetic division? No, we're not multiplying both sides. We're using synthetic division. Divide. So what goes out here? -2. And what do I put here? 1, 1, 3. Block off where my remainder would be. What's the first thing I do? Bring down the 1. And then we multiply the -2 to the 1. So I get -2. I add that to the value up above, and I get a result of what? -1. Repeat my process. So what would I put here? 2, add it to the value up above. So I would have a remainder of 5. So talk to me about these pieces. They're not my zeros. What do these numbers tell me after I've done synthetic division? That is my slant asymptote. This coefficient right here of 1 came from my x squared, correct? Oops, stop. Right, so this came from x squared, this came from x, and this was my constant. When I use synthetic division, the result has dropped by a degree because we're dividing it by a first degree polynomial here. So instead of being the coefficient on x squared, after synthetic division, this is the coefficient on x. And that means -1 is my constant. So this is y equals x minus 1. This is my slant asymptote. This is my end behavior asymptote. Which way is this slanting? Does it have a positive slope or a negative slope? Has a positive slope. So if I was going to write the end behavior based on this, I could say as x approaches infinity, what is our function f of x doing? Which way is it slanting? Is it slanting up or down as I move to the right? Up, because it has a positive slope. And as x approaches negative infinity, f of x also approaches negative infinity. All right. I'm using the slope to determine which way it's slanting, and since it's linear, my ends are always going to be going in opposite directions here. All right, let's practice with a graph. I'm hoping you guys got everything written down from how to graph right here. There's one other piece that I wanted to add at the very, very end. Domain and range. If they give me a rational function in P over Q form, we have some shortcuts for finding horizontal asymptotes if it is equal degree. We have some shortcuts for being able to find our y-intercept, for being able to find our x-intercepts. How do we find x-intercepts again? X-intercepts are where what equals 0? Y equals 0. When I'm looking at a rational function, if I put 0 in the place of y, and then I try to solve this for x, what happens to this guy? If I have a 0 over here, and I'm trying to solve it for x, you're going to multiply both sides by the denominator, which is just going to give me a big fat 0 over there, right? Which means my denominator does not affect my x-intercepts at all. Only my numerator will. It's going to be the zeros of my numerator when it's in P over Q form. All right, so everything that we have been talking about yesterday and what we finished up today, these are required pieces when we are graphing our rational functions. So I'm just going to kind of walk through them a piece at a time, similar to the way we talked about it. I want to be able to find any removable discontinuities, any holes. So that's the first thing I'm going to go looking for. How do I know if there is a hole? If there's something that cancels, a factor between my numerator and my denominator that cancels. Will I have that here? Nope. Then I would put that there are none. That is always the first thing I want to go looking for, because if I don't get the holes out of the way and canceled out, it's going to mess up the other things that I'm looking for. All right, my x-intercepts. You guys just told me that these are the zeros of the numerator. And again, the reason for that is because if I put a 0 in the place of f of x, come on, I would have x minus 4 over x plus 2. So I'm going to have 0 equals x minus 4. What do I find when I solve that for x? 4 equals x. Here's my x-intercept. Want to write that as an ordered pair, 4, 0. And as soon as I find one of these features, I want to go and plot it on my graph. So I'm going to go ahead and plot that point. All right, holes, x-intercepts. Are there any other intercepts that I should be worried about? Y-intercepts. Since I'm in P over Q form, what shortcut can I use to find my y-intercepts? Ratio of the constants. Yep, so I've got negative 4 over 2. Because remember, my y-intercept is where I would substitute 0 in the place of x. So that'd be 0 minus 4, that's negative 4. And 0 plus 2, so that's going to give me a positive 2. So when I simplify that, I get what? Negative 2. So 0, negative 2 for my y-intercept. Go put that on my graph. All right, holes, x-intercepts. y-intercepts, vertical asymptotes. How do I find the vertical asymptotes? X equals h. Yes, this is going to be the zeros of my denominator. This is telling me things that x cannot be. And now it's not letting me write on it anymore. Zeros of my denominator. So what will that be here? X equals -2. Coming from right here. All right, I'm going to go ahead and put that on my graph also. So -2, right here is my vertical asymptote. Is this going to have an oblique, a slant asymptote, or will it have a horizontal asymptote? Will it have a horizontal or an oblique? Horizontal. How do I find where my horizontal asymptote is? This will be the ratio of my leading coefficients. So it will be 1, yes. Y equals 1, right here. If it is bottom heavy or it is equal degree, then it will have a horizontal. If it is top heavy, then it will have an oblique or a slant, yes. Yep, so 1 and 1 right here. This is to find my horizontal asymptote, my HA. Y equals the ratio of those two. So y equals 1. All right. We are going to have to finish this up on Monday. Hold up, guys, before you start packing everything up, because I want to make sure that everybody hears this. Monday, we're going to just do some more graphing practice. We'll finish this and do more and more and more graphs. Tuesday, I know the information coming from the school says e-learning day. I want to be very clear. This is a remote live instruction day. There will be a live Zoom on Tuesday. Tuesday is the only day that we have on the calendar to cover 4.6, which is the last bit of this chapter. I will not have time to completely cover all of 4.6 on Tuesday during that 20-minute Zoom. And so either either Monday after school or before school starts on Tuesday, because we have a later start, you need to watch the video ahead of time. And that way, during that 20-minute time period, I can answer questions and do more examples and make sure that you understand it. That is the only day on the calendar that we have for this. Wednesday, we review, and Thursday is your test. Just half a second.